Hello, this is a lesson on the Sieve of Eratosthenes. This is a MathBot application, but it's also used in other things. One of the things it can show is if a number is even. All the even numbers are in green. The odds are in white background. I can click the odd numbers and have the odds show up with white background for the evens. There are the square numbers, which are when you multiply a number times itself. Then there are the cubic numbers when you multiply a number times itself 3 times. But the primary purpose here is to learn about prime numbers today. And that's what the Sieve of Eratosthenes does. It helps us with the prime numbers. So I'm going to set this up so that the first multiple is always showing. And one of the things we need to first do is we need to click on the number 1 because the number 1 has a special property of being a multiple, a factor of every single number, therefore it is not prime. Prime numbers are factors, have exactly two factors. The 1 is one of them, and the other is the number itself. 2 is the first prime number. Since it's prime, I'm going to all the numbers that are highlighted in green here are multiples of 2, and I'm going to delete all the multiples of 2 so that we do not have any even numbers listed in anymore. This takes a little bit of time. Let me get this done real quickly. Now, as you can see, the only multiple of 2 that we have highlighted is the first one, which is the 2. I'm going to deselect the multiples of 2 and now select the multiples of 3. And you'll notice that some of the numbers are already gone because if the multiples of 3 are there 3, 6, 9, 12, 15, 18, and so forth like that, but I want to get rid of the ones that are still highlighted that are currently highlighted in green, so that I have all of the multiples of 3 gone, because these multiples of 3 are not prime numbers if they are not the one highlighted in purple. So now then we know for sure that 2 and 3 are prime. Number 4 was a multiple of 2, so we now will work with that one there, and we will click on the number 5 and here, and we'll see that we hit many of the multiples. The composite numbers that are multiples of 5 are mostly gone because they're also multiples of 2 and 3. And now then we have all the multiples of 5 gone. We're going to deselect this and then select, and since 7 was a composite with 2 and 3, we're going to go ahead and select the multiple of 7. And here's all the multiples of 7. And you'll notice that we're getting fewer and fewer numbers that have not been composite numbers that are left in the list. Now then that we've got that done, we're going to deselect the multiples of 7. But since 8, 9, and 10 are multiples of earlier prime numbers, we go to the number 11, and all of its multiples have already been selected. So we will now select the multiples of 13 and deselect the 11. Oh, and all of the multiples of 13 that are in the first 100 numbers have already been selected. So we check the next prime number because 14, 15, and 16 are all composite numbers that are multiples of 2, 3, and 5. So we pick 17, and none of the numbers that are in this group are uh, all the composite numbers for 17 have been chosen. Deselecting 17 and selecting 19, the next prime number, shows that we have actually selected all of the prime numbers that are in the first 100 numbers. All the prime numbers of the first 100 numbers. Now, the most important ones for the GED exam are the 2, 3, 5, 7, which take care of, if you take care of those multiples, you have all the multiples of the first 100 numbers. Composites already gone, but GED also has us look at 11, 13, 17, and 19. Now there is a pattern. Once we pass 2 and 3, you notice it's 6, 12, 18, 24, 30 are all gone. So one thing that you'll notice is that all of them are multiples of 6. So that's the reason I'm going to do this. And then I'm going to select the prime numbers here. And you'll see that we have of the first 60 numbers we have that, but we can expand this out so that we go much, much further, and we can see that we can highlight all the prime numbers like this, and all of the prime numbers that are above 2 times 3, which is 6, all the multiples of 6 are over here. All of the multiples of 6 are right there. So that is a really nice thing to do, and a prime number is before the multiple. 6 has a prime number in front of it and after it. 12 has a prime number in front and after. 18 has a prime number in front and after. 24 has a prime number in front but not after. 30 has a prime in front and after. 36 doesn't have a prime in front but one after, and so forth like that. So we have a lot of things that we can work on, and this is what we do with prime numbers. Any questions?